So now imagine that you have this setup. You have a single VM as a master. You have node 1 and node 2. Now a pod is going to have an IP address. That is the case for every single pod. It has an IP address. And the node 2 will have its own IP address. And the IP address of the node is valid as long as the node itself is valid. So if it goes offline, of course, all of the rest of the system there on that node goes offline. Now, what happens with a pod is that it's very common for the pods to come up and then the pods to go back down. Now, that means that the IP address in this pod, the first time it comes up might be IP1, but then when it goes down and another replica comes up, it's going to have IP address 2. In other words, there is no guarantee that you'll have the same IP address every single time this comes up. And yet, what happens if we're running, say, a Liberty container, a web page here, and we want that to always come up at the same IP address from some client down here? This is where services come into play. The idea is that you create an abstraction called a service, and you could have many services, and they will have an IP address, they will have a DNS entry, and they'll also have a port. But these are long running. They do not disappear if a pod disappears. And the advantage of this is that the client who knows nothing about this cluster whatsoever can nevertheless access the Liberty web container by using the port, by using the stable DNS entry. And the way that that works is, like we've seen before, the service is defined as a YAML file, which you feed into the master. That is, you give it to the API server, and we'll see later that that typically happens by using kubectl, and the master will create the service. But of course, a client can't talk to some ephemeral abstract thing. It needs to go through a VM. So the master communicates with the nodes like usual, and it sends the nodes the service. And just like we saw before, that will expose something new through the kube proxy. And the something new is this IP address, which is available on DNS internally inside the cluster, and along with some port. So the client can open up his web browser, go to HTTPS, go to x.company.com. That will do a DNS lookup like always, and find X. It sees X is some referral, an A record, or a CNAME to node 2. And specifically, node 2 will then pick up on its endpoint as kube proxy for port 32771. Kube proxy says, let me check. I know 32771, that's the port, and I know the IP address because that's me. I just replied to it. And I know how to get you where you're trying to go. In fact, that's on my pod number 2. It's in container number 2, and here you go. When traffic flows this way, what you have is what's called a virtual IP, and that happens through kube proxy. Now, in the case where the same service that the person is trying to get to is actually not hosted on the node that they're actually contacting, then kubeproxy can send it over to the correct node, and that node can service it through that pod and through that container. Now, if this request comes into the kube proxy, and by the way, this IP address that is exposed on the node itself is exposed through something called a node port. If the request coming into kube proxy is in fact supposed to be handled by potentially more than one pod, then it could potentially do this. So in that case, there has to be a decision. Which pod do I send it to? If it goes to this one, for example, and then through here, the decision to do that is made through something called session affinity. And there is internally, if session affinity is not set, a way to do round robining like you would expect from a normal load balancer. Now, the other thing to note here is the traffic and the routes that are coming in. The way we drew this, we have a single cluster here, and the client is coming in through that cluster. Now, of course, it did that through VM number 2, but the cluster itself is a sort of abstraction defined by these virtual nodes, these VMs. In other words, we have DNS happening here so that you can have traffic into the cluster, and then separately we're going to see DNS inside the cluster as well, which manages all of these nodes internally, and there's a way to get into and out of the DNS from inside the cluster. So you could, in fact, reverse this. Say that you had, for example, a database running outside the cluster that you needed to have access to. If that's the case, you can create a CNAME from inside the cluster to get to the database running outside the cluster. And to provide additional security, what you typically would do is have a client connect over to an IHS machine or Nginx, IHS being IBM HTTP server or Apache, and that would be protected behind some sort of gateway firewall, and then that would then give you access to the cluster, so that if this machine, which is probably running inside a DMZ of some kind, a demilitarized zone, if this machine gets compromised by somebody out here, then this person out here does not have access into the cluster. They only have access to whatever they compromised here.